Today we're going to be working on how to solve basic force problems using vector addition diagrams. So I'm going to open up practice 5, and as I look at this, what we're going to do is we're going to work these out on a sheet of paper, so I'll be using my camera for that here in a second. So I'll go ahead and move the camera into the right spot. Alright, so problem number 1 says a worker exerts a 220 Newton force on a 40 kilogram box pushing it across the floor with a constant speed of 1.8 meters per second. So the first step is to draw a picture of it. So we got a person pushing a 40 kilogram box across the floor, and it says it's 1.8 meters per second, and he says it's pushing with a 220 Newton force. So the first thing is draw a picture. Second step is to list all the given information. So we know that the mass of the box is 40 kilograms. We know that the force from the worker is 220 newtons. And we know that the velocity is 1.8 meters per second. Now, it says that it's a constant speed, and we know that if it's a constant velocity, then it must be a balanced diagram. So I'm going to draw in my forces. So I got the force of gravity, which is from the earth on the box. We have the force from the worker pushing it, and we know that that one is 220 newtons. We have a normal force going up because the ground is pushing on it, and because it's sliding and it's a heavy box, it's going to have friction as well. Because it's balanced, I'm going to say those two are equal and these two are equal. So if this one's 220 newtons pushing forward, then friction is going to have to end up being 220 newtons as well. We got to figure out the force of gravity. Force of gravity is always equal to the mass times 10. So it's 40 kilograms times 10 meters per second squared, which equals 400 newtons. So we know that that's 400 newtons. My vector addition diagram for this one's rather easy. I have a force that goes up, a force that goes to the right, and the right force is the normal force from the from the worker, 220 newtons. We have a force of gravity, which we just said was 400 newtons. We have friction to the left, which is also 220 newtons, which means that the normal force from the ground has to be 400 newtons, because where this one starts, it needs to end at the exact same spot because there's no net force. So that's problem number 1. Problem number 2 has a box on a ramp. Draw my box. Says it's a 30-degree angle. The box is held there because of friction. It's a 60 kilogram box. So the mass equals 60 kilograms. The angle equals 30 degrees. The velocity is 0. Okay, so if I draw my free body diagram, I have a box going, a force of gravity going down from the Earth, and it happens to equal the mass, 60 kilograms, times 10 meters per second squared, which is 600 newtons. Then we have a force that's going up and to the right. We don't know how much it is, but that's the normal force from the ramp, the box. And we have a friction force going up and to the left from the ramp. And we know that those are 90 degrees from each other. And I like to draw a dotted line to show what angles I do know. So I know that that angle is 30 degrees. It's also 30 degrees from the vertical. Now we're ready to draw a vector addition diagram. The force of gravity, 600 newtons. At a 30-degree angle from it. At a 30-degree angle, we have our friction, or our normal force, about 30 degree from vertical, and then a 30 degree from horizontal, we have our friction. So friction is that direction, normal force is that direction, and it doesn't go the whole length, it just goes up until it meets the other one. Now if I drew this correctly, this should be a 90-degree angle from each other, and that's pretty closely 90 degrees. So this is 30 degrees, and that makes this angle 60 degrees. Now, because of SOHCAHTOA, trigonometry, we can figure out what these other sides are. So, the sine of 30 equals the opposite side, friction, divided by the force of gravity. Or sine 30 equals friction over 600 newtons. So 600 newtons times the sine of 30 will equal our friction. And sine of 30 is 0.5 times 600. So the friction is 300 newtons. Next up, we have the cosine of 30 will equal the normal force, the adjacent side, over 600. So 600 sine, or cosine 30 gives me right about 519.2 newtons. So that's problem number 2.